Welcome to this video on GCSE probability. I put top grade on there because I think this really is a top grade 8 or 9 question. Okay, lots of algebra needed here and lots of interpretation of the information given before you even start. So I'm going to take you through it step by step. At any point, stop the video and have a go yourself before watching the full solution. So here we go then. We have only green and blue pens in a box, nothing else. There are 3 more blue pens than green pens, and there are more than 12 pens altogether in the box. Simon is going to take at random 2 pens from the box, and we know that the probability that they're both the same colour is 27 over 55. Okay. And finally, we've got to work out the number of green pens in the box. Okay, so this is what I would do to set this problem up. And it's going to take quite a bit of algebra and structuring before you actually solve the problem. So here we go. If we call the number of green pens X, so if I just use the abbreviation G for green, okay, then we can say that that's equal to X. And therefore, the number of blue pens is equal to 3 more than X. So it's X plus 3. Okay? And ultimately, of course, it's X that we've got to find out. And if we know that there's only green and blue pens in the box, we can say with confidence that the total number of pens in the box must be those 2 added together, which is going to be 2x plus 3. Okay, 2x plus 3. That's the total number of pens in the box. Okay, so what do we know then? We know that the probability that Simon will take 2 pens of the same colour is that. And there's 2 ways that can happen. Okay, so we can say that he can either get 2 greens or 2 reds. So we know that the probability of green and green, so I can write that literally as that, okay, or blue and blue, okay, blue and blue, is the same as the probability of getting 2 greens plus the probability of getting 2 blues. Now you have to be careful about just adding the probabilities together, okay, but I'll explain why we can in this case. All right, and those 2 added together will equal 27 over 55. Okay, so just to be clear, the reason we can add them together is because the 2 outcomes of getting a green or a blue are what we call mutually exclusive. That means you can't pick a pen that's both green and blue at the same time. So because the events are mutually exclusive, that means they can't happen simultaneously. We can simply add the 2 probabilities together, all right, which is what we're doing here. Okay, so let me just take that little mark away there. Right, so that's what we've got so far. Now, these 2 quantities here, P of GG and P of BB, we need to now work out in terms of X. So this is what I'm going to do. I'm going to say that PGG is going to be the probability of getting a green followed by a green. Now, if you go to the box and take a pen, the probability that it's green is going to be X, because there's X green pens in the box, divided by the total number of pens in the box, which is 2x plus 3. Okay. Now, if you go to take a second pen from the box, there's now 1 pen less in the box, and there's also 1 pen less that's green. So the number of green pens is now x minus 1, and the number of pens in the box is 1 less than it was, so it's 2x plus 2 instead of 2x plus 3. I'm just going to put the fraction line in and some brackets. Okay, so that makes some sense then. So we've got those two fractions multiplied together, and we use a convention of just putting a little dot between the two to show that they're multiplied. So that's a times, not a anything else. All right, that's the PGG bit that we've just done. Okay, now we do the same sort of thing for the blue. So to get, we put a plus sign. Okay, this is a multiplication. We've multiplied these two together. Okay, and the probability of a blue followed by a blue, well, if you go to the box, take a pen out, there's x plus 3 blue pens to start with. Okay, and when you've taken out a blue pen, you've only got x plus 2 left. What I'm going to do is just copy the denominator I've already written here, because it's going to be the same pair of denominators. Okay, so this bit here at the bottom of this fraction I can just copy across to save a bit of time writing it. See if that works. So if I take that, make a copy of it, take it across here, perfect, that fits in there. Okay, just saves me writing it all out again, and then put my fraction line in. So that is the probability of getting a blue followed by a blue, multiplying those two together there. All right, and we know that all of that, when we finished, is equal to 27 over 55. Now it looks very complicated because x appears all over the place, and we need to find out what it is. Now there's no guesswork here. You can't start guessing what x might be. That would take a long time, and you wouldn't get it probably for ages. So what you do is you solve it algebraically. I'm going to go up to this side now. So what I'm going to do is recognize that I have a common denominator of this left-hand fraction and this right-hand as well, of 2x plus 3 times 2x plus 2. So what I'm going to do now is write that down as a common denominator of 2x plus 3 times 2x plus 2. Okay, 2x plus 3 and 2x plus 2, and they're multiplied together. And the way we show that is to put each of those expressions in its own pair of brackets like that. Okay, and above that we have the numerator, and that's made up of, well, let's carefully work through what we've got. Well, we've got x times x minus 1, so I'm just going to write this out in full. X times x minus 1 like that from the left-hand fraction, and from the right-hand one we've got x plus 3 times x plus 2. So plus x plus 3, okay, times x plus 2. Now the next thing we need to do here, okay, is multiply out the whole of that top line. Leave the denominator factorized at the moment, okay, because we're going to end up solving a quadratic equation later on. And we still know that all that is equal to 27 over 55. Okay. A question like this in the exam would carry quite a few marks. It will take you, well, several minutes to do. Now, if we go to the next line, that will give us, well, x. I'll multiply out the brackets as I go across, so you should be familiar enough with that. So we've got x squared minus x. Okay, plus, and we're going to use FOIL on here. So first is x times x, which is x squared. Okay, the outer term is x times 2, 2x. The inner term is 3x, that's 5x altogether, plus 6 at the end, 3 times 2. So it's x squared plus 5x plus 6. Just multiplying out that last pair of brackets. Okay, And all of that is over the same denominator that we've got here. So if I just copy that whole thing again, save me keep writing it down, that is, if I take the line as well, if I can get that in, that's it. Okay, make a copy of that, and that goes under there. Okay, right, so that is then equal to, now if I gather together all the like terms, I've got 2x squared on the top. So this is just basic algebra, but just carefully making sure you don't make a mistake, because one mistake in this and it won't make sense later. Now I've got 4x because I'm taking away an x from a 5x to give me 4x, and I've got a 6. Now you may notice that on the top there is a common factor of 2, and in fact on the bottom there's also a common factor of 2 in this second bracket, because this second bracket is like 2 lots of x plus 1, you see. So I'm going to write that as 2 lots of 2x plus 3. Okay, and instead of writing 2x plus 2 at the end, I can now write x plus 1, because I've taken out this common factor from these two terms of 2. And I'm going to cancel that with the 2. I'm going to divide the top and bottom of this fraction by 2, you see. And what I'm doing is halving the top and the bottom. So if I take that 2 away, I've halved the denominator. So I must halve the numerator. And because they're all even numbers, that's easy, because that's going to be 1x squared, 2x, and 3. So I'm going to now go on to say that this equals, okay, x squared, 1x squared, plus 2x, plus 3, and all of that can now be written over 2x plus 3, x plus 1. Okay. And for the moment, I'm still leaving the denominator factorized. And I was kind of looking to see if that would cancel with anything on the numerator if I factorize that as well. But it's a bit early to do that, because we've still got to deal with the fact that all this is equal to 27 over 55. Okay. Now, the process we follow now is to cross multiply. Okay. So that means I times the whole thing, both sides, by 55 and by this denominator here. So the 55 comes across to the left with this, and this denominator comes across to the right with this. It seems very cumbersome and complicated, but it will work out really simply in a few moments' time. So just see what happens. We've got 55 lots of x squared plus 2x plus 3 on the left, okay, and on the other side we've got that equaling 27 lots of, and I'm now going to multiply out these brackets, okay, because that's going to have to happen at some point. So I've got 2x squared, okay, using FOIL, first outer inner last, 2x squared plus 2x plus 3x, so that's plus 5x, okay, and finally the last two terms there give me 3 times 1, which is plus 3. Okay, now it looks ridiculously complicated, but it really works out well, as you'll see in a very short time. So let's take everything and multiply it out now. So I've got 55 lots of x squared, okay, plus 110 lots of x, and 165 from the left hand side. And on the right hand side, I've got 54, 27 times 2, 54x squared, Okay, I've got 27 times 5, which is 135x. And finally, I've got 27 times 3, which is 81. Now, hopefully you can see the formation of a quadratic, because I've got x squared term, x term, and number on both sides. If I just subtract one from the other, I'll have a 0 on the right by subtracting the 54x squared from here. Okay, so I should just say here that equals, that implies rather than equals that that's true, which implies that that is true, which implies that, okay, now 55x squared minus 54x squared is just 1x squared. Okay, 110x minus 135x is going to be minus 25x. You see, and finally, I've got 165 minus 81 is 84. Okay, plus 84. Now, what we do with a quadratic, and that's now equal to 0, is we try to solve it by factorising. And if we've been very careful, and it does factorise, then we'll find out now. Okay, and we would expect x to be an integer or a whole number because it represents the number of green pens. So if we make one mistake here that would cause this not to factorise and require the use of the quadratic formula, then it means that we've gone wrong, and x wouldn't then be a whole number or a rational number. So does this factorise? Hopefully yes. And you're looking for the factors of 84 that add up to negative 25. Well, they must both be negative numbers. Okay, and a quick inspection will see that 84 is 21 and 4, 21 times 4. So if you take x minus 21 and x minus 4 and add them, not add them, but multiply them together, if you multiply that bracket out, you will in fact get this, which kind of gives us some confidence that we've done it correctly because it's factorized perfectly. All right, and from that factorization, we get two possible values of x. Okay, so this tells me that to make the first bracket 0, x could be 21, and to make the second bracket 0, x could equal 4. They're both integers, and they both seem plausible. Now, we go back to the original question, which tells us that there are more than 12 pens in the box. Now, remember, the total number of pens is 2x plus 3. Okay? Now, if x equals 4, then 2x plus 3 would be 11. Okay, which is less than 12. Equals 11, which is less than 12. And we're told that there are more than 12 pens in the box. So we know that x can't be 4. Okay, so therefore x does not equal 4. All right, I'm just eliminating one of the solutions. Therefore, we can be confident that x equals 21 is the correct number. Okay, so the number of green pens, x, is 21. The number of blue pens is 21 plus 3, 24. And therefore, the total number of pens is 2 times 21, 42, plus 3, 45. And you could do the whole problem again if you wanted to check that it worked. But we've answered the question. We found x, which is the number of green pens. It's taken us nearly 20 minutes. Hopefully it will be a bit less in an exam. But nevertheless, a difficult and complex question requiring a lot of planning and careful manipulation of these expressions. Okay, I hope that was helpful. Take care. Well done.